the SAR. The main thing about SAR is that for barbiturates to be more hypnotic, more sedative, it's got to be lipophilic. That's the main thing. So let me repeat. For barbiturates to be more hypnotic, more sedative, because the main idea is that anyone suffering from anxiety, what they really want is they want a drug that can calm down the nerves, the senses. To give the anti-anxiety effect, usually the barbiturate offers sedation, kind of like you mild sikit lah, you calm down a bit. So to be more hypnotic, to be more sedative, then barbiturates need to be more lipophilic. That's the main idea. So the rest I'm going to show you is all the substituents you'll see later is all going toward more active, more lipophilic. Alright? So in this case, I'm going to go very, very fast here. So if you see from a dimethyl to a ring, aromatic ring, okay, an ethyl group. So this is more lipophilic compared to this one, and they are usually more hypnotic, more sedative. Alright? In terms of duration of action, they are also faster. The more lipophilic, the more they tend to be in the body. So they tend to be longer, a bit longer than a dimethyl substituent. Okay. Which one? The yellow one or the green one? Duration of action is this way. So shorter, in my interpretation. Shorter this way. Shorter this way. That one is longer. Shorter duration of action, that's longer. Opposite is more lipophilic, more active, but then is. But correct me if you find something contrasting. But please put something on the. Please correct me if I'm wrong. Okay, so as I mentioned earlier, more lipophilic, more hypnotic. So the rest, if you see unsaturated is more preferred. Here, alkyne is more preferred compared to just alkyl group. Here, if you have alkyne in the ring, better than a simple hydrocarbon. Here as well, a ring is better than a single straight chain, for example. All right. Here is you have to be careful. Usually you see a substituent like this, and the aromatic ring depends on the substituent, the aromatic substituent. It is polar, then it is more getting less of the lipophilic character. It's polar, it's more polar. You have, for example, SO3, for example, or NH2. Then it will be less lipophilic. All right. So make sure you know what's the R on the R. Maybe there's a quiz question on this. Okay. So this is what I just mentioned earlier. And the same goes if you have a thio, like a sulfur. Okay. So thiopental, rapid onset, shorter acting, hypnotic. But when you have 2, 3, replacing all the oxygen or the carbonyl, the potency has dropped. Methylation, there's no really much change of potency. So again, the main idea is, as mentioned earlier, is make sure that you know which one is more lipophilic. The more lipophilic, the better activity. Alright. Acidity, I think you can go on. Is basically more acidic. More acidic barbiturates are more hypnotic compared to the less acidic barbiturates. Okay. This one is talking about if barbiturates is inactive in vitro, it could be active in vivo after it's metabolized. So having that acid, it can be an acidic part of the molecule. It can actually turn it into an active barbiturates. Metabolism, I think you can go on your own. Yeah, it's pretty much straightforward. I'm going to go into carbohydrate.